A pleasant morning, everyone. By the way, this is Professor LEVITAH MAPATAC, and we are going to discuss about conversion of moles, grams, atoms, and molecules, which is a part of our chapter 1, and this is not being thoroughly discussed in the previous video. So we will have one video just only for the conversion of moles, grams, atoms, and molecules. So in the mole conversion, it is quite easy to have it. So what we are going to learn in this video is we are going to know how to do mole conversion for each element. Then we are going to calculate the molar mass of a compound. We will also do mole conversion for compounds. And the last one is we are going to also convert from gram to mole, mole to gram, vice versa. That is mole to atoms or mole to molecules. Okay, so by the way, what is a mole? No? Why is it as if we think of a mole as a very big quantity? We could just have it in a logic. No? We can just have it compared in a dozen. No? And 1 dozen, that is equivalent to 12 things. What do you mean by things? It could be a dozen of an egg, a dozen of dress, a dozen of shoes. Okay, that is what is meant by that. Therefore, in a mole, in 1 mole, that is equivalent to 6 times 10 to the power of 23. This is known as Avogadro's number. 6 times 10 to the power of 23 things. And these things could either be an atoms, a particle, and a molecule. So atoms are so small. If we look into this glass, for instance, we have this glass which contains water, hydrogen atoms. No? Hydrogen atom in a water. Actually, this will have 15 trillion hydrogen atoms. But we already know that in a hydrogen atom, that is 25 moles of hydrogen atoms. That is in 15 trillion. So we use moles to count an atoms. So how are we going to count an atom? Of course, we need to have a mole. Okay. So for instance, in 1 mole of hydrogen atom, that is equivalent to looking into the periodic table. You look into the atomic mass of hydrogen, that is equivalent to 1.00, like that. Therefore, in 1 mole of hydrogen, that is equivalent to 1.00 grams of hydrogen. Where did we get that one? That is in the atomic mass or the molar mass. Okay, so molar mass is very important in the calculation of mole to gram or gram to mole before you go on to mole to atoms, mole to molecules, or mole to particles. So the basic unit there is the mole. Then afterwards, you have also the molar mass. Molar mass will differ in each of the element or each of the compound because they have different molar mass in the periodic table. Okay, so the basis for our molar mass is, for the element, is what is found in the periodic table. So to move on, we already know that in 1 mole, that is equivalent to 6.022, actually that is 6.022 times 10 to the power of 23 things. And this is known as the Avogadro's number. And we also already know that in 1 gram that is equivalent to 6 times 10 to the power of 23 or 6.022 times 10 to the power of 3 atomic mass unit. For instance, we have helium. If you look into the periodic table, the upper portion there is the number of the atomic number or the number of protons, as we have discussed in our lecture, okay, lecture video 1. Now, that is the number of protons, but what is needed here is not the number, the atomic number. What is needed here is the atomic weight. So what is atomic weight? Atomic weight or molar mass formula mass is the same. No? So for lithium, that is 6.94. Okay, so in 1 lithium atom, that is equivalent to 6.94 atomic mass unit. Or we can have a conversion here that in 1 mole of lithium, that is equivalent to how many grams? That is 6.94 grams because of our molar mass. Therefore, this molar mass here will be our conversion factor. This is the same as counting atoms by weight. So, for instance, we have an example here. How many moles of lithium are in 25 grams of lithium? Okay. In calculation, you should always start with this one. You should always start with the given. Okay. But before that, let me show you this way, that this one. Okay. This is how you are going to process the conversion. If the given is grams, as you can see here, you can see here an arrow. Okay, an arrow goes this way. If you are going to convert, if the given is mass and you are going to convert that into mole, okay, what are you going to do? You are going to divide that with your molar mass. Okay, so gram to mole, that is, divide that into molar mass. Therefore, that is in 1 mole over grams. So you can cancel your grams. What remains is the mole. Then, if you're going to convert now your mole into atoms, that particle here could either be an atoms or a molecule. Okay, so how are you going to do it? Okay, so your given is mole. Look into the upper arrow, multiply it with Avogadro's number, and you will arrive with the number of atoms or molecules. The other way around, if the given is this one, if the given is the number of atoms or molecules and you want to convert that into mole, use the lower arrow. Therefore, molecules into mole, divide it with Avogadro's number. What is Avogadro's number? That is 6.022 times 10 to the power of 23, this one. 23, either if it is only one element only, it is an atom. If it is a group 2 or more, no? 2 or more atoms, you will be using molecules. Then if it is now mole to gram, all you have to do is multiply it with the molar mass. So this is the one that you are going to use as a guide in solving this problem. Okay, therefore, we have here, for instance, how many moles of lithium are in 25 grams of lithium? Okay, as I have said, you should start with the given. Okay, can you still remember our guide? If it is gram to mole, how are you going to solve it? You are going to divide it with the molar mass, meaning lithium has a molar mass of 6.94 grams per mole. So that 6.94 grams per mole, you can have it the mole up, that is 1 mole over 6.94 grams. And siya, no? So here it is. As I have said, gram to mole, that is divide it with the molar mass. What is the molar mass of lithium? That is 6.94. So we already know its molecular, the molecular mass, atomic weight, that is equivalent to 6.94 grams per mole. As it is being said, you should reverse it. That is 1 mole over 6.94. So in this way, we can cancel our grams here. What remains is the mole. Therefore, 25 divided by 6.94, that is equivalent to 3.6 mole of lithium. Oh, why is it that the E is already missing? Because the abbreviation of mole is you get only the E. So, kung kayo no, taas kayo no? Okay, that's it. Okay. So, another one. Here, the given is grams. The next one, the given is mole, and you are going to convert that into grams. So other way around, same thing, but you are going to multiply it as you have seen in our guide. You are going to multiply it with our molar mass. Therefore, and always start with a given, no? So that you will not be confused. That is 11.5 moles of lithium multiplied by the molar mass, which is 6.94 grams per mole. So cancel the mole. What remains is gram. Then multiply 11.5 times 6.94. Therefore, it is 79.8 grams of lithium. So that's the answer. Okay, let's move on to the calculation. What we have here is just in an element. How about, how are we going to solve for, the molar mass of a molecule? It's easy. All you have to do is add up the molar masses of all atoms in a molecule. For instance, we have here carbon. Now, this is carbon. The molar mass of carbon is 12.01 from the periodic table. We have nitrogen. The molar mass of nitrogen is 14.01. And the unit, of course, is gram per mole. Then oxygen, that is 16. Unit is gram per mole. How are we going to get the molar mass of a molecule? Add up all the molar masses of all the atoms in a molecule. For instance, the formula is carbon monoxide. Okay, that is CO. Carbon monoxide, take a look. How many atoms are there in carbon? 1 multiplied by its molar mass, that is 12.01. It's still the same. Then oxygen, multiply how many atoms? Only 1. Then multiply it with the molar mass 16. Add it up. Therefore, the molar mass of carbon monoxide is 28.01 grams per mole. Okay, and this could be vice versa. You can use that in 1 mole, that is 28.01 gram of carbon monoxide, or 28.01 gram is equivalent to 1 mole. How about for diatomic nitrogen? Okay, so here, as what is said here, all you have to do is multiply it with the number of atoms. Your molar mass of nitrogen is 14.01. How many atoms? There are 2. Multiply it with 2. Therefore, the molar mass is 28.02 grams per mole. For carbon dioxide, this is different with carbon monoxide because your carbon dioxide has already 2 moles, 2 atoms, of oxygen. Therefore, same process, carbon, it has 12 multiplied by 1 atom. Then oxygen, you have 2 atoms multiplied by the molar mass of oxygen, which is 16. Therefore, that is 16 times 2, it's 32, plus 12.1, it's 44.01 grams per mole. How about this compound? This is magnesium nitrate. Take a look. Okay, so the first thing that we should do is identify how many atoms are there in each element. You have magnesium, how many atoms? Only one. For nitrogen, it has one, but this should be like mathematics, it is in a parenthesis. Therefore, you are going to multiply, distribute this 2 here. Therefore, 2 times 1 for nitrogen. Therefore, there are 2 atoms for nitrogen. For oxygen, you have how many? 2 times 3 is 6. Let us get now the molar masses of this. That is magnesium. That is 24.3 multiplied by 1. Then nitrogen is 14.01. Multiply how many atoms? 2. Okay. And oxygen, we have 16 multiplied by how many atoms? That is 2 times 3, it's 6. Therefore, we come up with 148 grams per mole. Or we can have it here in 1 mole of magnesium nitrate. That is equivalent to 48.3 grams of magnesium nitrate. Okay, so our example is just the conversion of grams to mole and mole to gram. Now, how about if we are going to have a number of atoms? For example, how many gold atoms are there in 5 kilograms? Okay, take a look. It is atoms. Here in the conversion, this is our guide. If the given is in mass, and you are going to have that into an atom, you will be using this process. You will have two-way process. Why two-way? Because your gram should be converted first, the upper arrow. You will be using the upper arrow. The mass should be converted into moles first, then moles into atoms. In order to convert your grams here, but be sure it should be in grams. So whatever unit is there in the mass, convert that first into grams. Okay. So if your mass is in grams, divide it with the molar mass to come up with moles. Then mole, 2 atoms or molecules, multiply it with the Avogadro's number of 6.022 times 10 to the power of 23, either atoms or molecules. So let us start with the problem. Okay, the first thing that we should do is convert 5 kilograms. As I have said, the unit mass here should be in terms of gram. We already know that in 1 kilogram, that is 1,000 grams. So cancel kilogram. The next thing is we will convert these grams into mole. How? You divide it with the molar mass. Okay, look into the periodic table. What is the molar mass of gold? That is 196.967 grams per mole. As I have said, if you're going to convert grams to mole, you should reverse your molar mass. That will be in 1 mole of gold, that is over 196.967 grams of gold. So cancel the gold, the grams I mean, cancel the grams. What remains is the mole, but this is not yet our answer because we need to have it in atoms. Moles to atoms or molecules, you are going to multiply it with the Avogadro's number. Your Avogadro's number is in every mole of anything, any substance, that is equivalent to how much? 6.022 times 10 to the power of 23 atoms. Therefore, your mole should be down and cancel your mole. Multiply all of this. Oh, sometimes this becomes the problem here. No? How are you going to have that in your calculator? That is 6.022. Then where are we going to get the exponent here? The exponent asa man dapit. The exponent should be, that is, take a look here. Okay, I'm going to let it show to you. That is 6.022, that one, then times. Okay, can you see it in my calculator? Where out here? Okay, there, that one. That is 6.022 times. Then your exponential should be this portion here. Where is it? Kani. Okay, there's one. Exponent. Okay. Then after exponent, there. Okay. Exponent, then you have it 23. Maglibog po abot sa akong calculator. Okay. 2, then 3. That one. Okay. Can you see it now? Okay. That is it. Then equal to. That is how you are going to have the exponent. Do you get it? Okay. Then multiply this with 5. Multiply this with 1,000. Okay. This is it. That is the answer. Before you divide it with 196.967 here, then equal to, okay, that is now the answer. This is being rounded off. Therefore, that is 1 point, let me see, 1.5 times 10 to the power of 23. Okay, so that is what I want to show you, is just how to come up with the exponent, that Avogadro's number. I repeat, how are you going to have it? I will first have 6.022, that one, then times 6.022, then no need for times, largo na. Huh? Then after that, you 6.022, then have it in exponent. This is the exponent, this one. Okay, exponent, then 23. Should I? Okay, like that. This will be its, no need for times. You should have 6.022, then directly exponent, 23. Then multiply it with 1,000 times 5 equal to that one. That's the answer. Before you divide it with 196.967 equal to. Okay, it is 1.50 times 10 to the power of 23. Okay, 23. Ano 25 man siya? Sige lang. Basta ingana ang process. Okay, I will look into it. Okay, so that is how you are going to convert an atoms, a gram into atoms. So use the upper portion. The next problem will be, we have it in a reverse. The given is still, it's still the same. It's still grams of saccharin. This is saccharin. Okay. C7H5NO3S. Okay, saccharin is a kind of a sugar. Okay, so the first thing that you should do here is get first the, you should get first the molar mass. How are you going to get the molar mass? Okay, for carbon, that is 12 times 7 plus 5 times the molar mass of hydrogen is 1, 5 times 1, plus nitrogen 1 1 atom times 14, that is the molar mass of nitrogen. Then oxygen, we have 3 multiplied by 16, plus sulfur, it has 1 times 32. Then you will come up with the molar mass equivalent to 183.18 grams per mole. Okay, so the first thing that you should always do, if it is a compound, okay, you should get first the total molar mass of the compound. So from here, getting first the molar mass, okay, before we proceed. As I have said, always start with the given. The given is 40 milligram. Oh, it should be converted into grams. We already know that in 1 gram, that is 1,000 milligram. Okay, so cancel your milligram. So we are now in grams here. Then grams to mole, okay, use your molar mass, but you should reverse it. That is in 1 mole of saccharin, C7H5NO3S, is equivalent to 183.18 grams of saccharin. So cancel your grams. What remains is mole, but this is not yet because mole to molecules. Ma'am, nga no molecules naman? Molecules na kay it's already a compound. It is a group of atoms. Okay? Therefore, multiply it with our Avogadro's number, that is 6.022 times 10 to the power of 23 molecules of saccharin over 1 mole of saccharin. So cancel the mole. What remains now is the molecules, which is the molecule of a compound. Therefore, multiply all of this. How? That is 40 multiplied by 40 divided by 1,000 divided by 183 before you multiply it with 6.022 exponent 23. Do not have that times, but exponent, largo ka exponent 23. You will come up with a value of 1.31 exponent 20. But that is for a compound of saccharin. What is needed is carbon atoms. But as you can see in the formula, how many carbon atoms are there in saccharin? There are 7. Therefore, all you have to do is in a 1 molecule of this compound, okay, that is how many carbon atoms? 7. So multiply it with 7. Cancel the molecule. We come up now with 9.17 times 10 to the exponent of 20 atoms of carbon. I hope that you are enlightened in solving now conversion from grams to mole, mole to particle. Thank you for listening and have a good day.